All right, so the main question for today's video lesson is how can we know if a triangle is a right triangle without measuring any of the angles? Well, let's actually get into this and say, I don't know, let's look at these triangles and say, how do I know if these are right angle triangles or right triangles without measuring the angles? So I try to think to myself, well, I know something about right triangles, which is that the Pythagorean theorem only works on right triangles. The Pythagorean theorem only works on right triangles. Now, this is something that is huge to remember because we can actually use that. So let me clear some space here and actually give this a shot. Now, what I'm about to show you is an example. Then you're going to actually try this one back together as a class. So just here's an example. Let's say they give me a triangle. Let's say it doesn't really even look quite like a right triangle, but they say it's not drawn to scale, so not to scale. And they say, well, this side is 5, and this side is 12, and this side is 13. And they ask me, is this a right triangle? Now, I have a few steps that I need to take. The first step is I need to figure out which one is A, B, and C, because this is a really crappily drawn triangle. I need to figure out what they were thinking. Well, I remember that the hypotenuse is always the longest side, so it clearly wants 13 to be C. So let's say a squared plus b squared equals c squared. The hypotenuse is the biggest side, it's always c. So let's test this. 13 squared is equal to, well, we know it doesn't matter which one is a and b in terms of 5, 12, so let's just do it in this order. 5 squared plus 12 squared. And then I'm going to throw a big question mark over my equal sign, just so I can remember that I'm seeing if this is actually true. I don't know if this is true yet. So I throw this question mark on here just to remind myself of that. And I say, well, 5 squared is 25. 12 squared is 144. Now, is that equal to, question mark again, 169? Well, let's add these up and find out that 169 does in fact equal 169. So these two added up are 169. This stays by itself. So this is a right triangle because the Pythagorean theorem worked for it. This is a right triangle. Now, get rid of some of this chicken scratch here. Let's go in and actually try this one where it says together. Move some of the work over here. Let's test this one out. It looks like what we need to do is find out if this triangle right here is a right triangle, because it says is the triangle shown below a right triangle. Using the strategy we just saw, there are a couple tools here to get us set up. So let's start with this. I know that my hypotenuse is always my longest side, and the hypotenuse is always C. So I say, well, C is 12. So I'm going to start with that. I also know that the two legs, it doesn't really matter which one is which, so we'll just say 7 and 9. So I filled in my A, B, and C. Now it says set it up. All right, let's set this up. So I say 7 squared plus 9 squared equals question mark. Don't forget that question mark. It's a great way of reminding yourself that you don't actually know this yet. You're checking to see if that's true. So 7 squared plus 9 squared, a squared plus b squared, equals 12 squared. So let's go to check it. Well, I know that 7 squared is 49, and 9 squared is 81, and 12 squared is 144. Throw that question back in there just to make sure. And it says 49 plus 81. 49 plus 81 is 130. Question mark. Well, actually, let's leave that question mark out because we're going to see 130, well, it doesn't equal 144. So I put my slash through the equal sign. These are not equal. Therefore, is the triangle a right triangle? No. The triangle is not a right triangle because the Pythagorean theorem did not work for it. So, using this information, you're going to come down here to where it says you try. You're going to solve this triangle right here to see if it is a right triangle.